Good morning, I'm Cody Hendrickson. Today we're going to be looking at how we can use Swift and how we can use it to work with JSON data sets so we can read from the JSON and actually do some work with that inside a Swift project. We've got a quick little example right here. I'm using the Swift Playgrounds tool so I can do just a quick demo for you. We'll go ahead and step through that and work on that from there, and we'll keep on and we'll use that so we can do some more with it, understand how we can incorporate this into a larger project. So first, let's take a look at the actual start of the thing right here. As you can see right here, I'm inside my Swift Playgrounds. I have an import for Swift UI because I'm using I have to use something that's inside there. I could even use import foundation to make this work too. But we're simply just saying let demo equal, and then I'm using the three quote string operator so I can have it easily do multi-line support, so it makes it very easy for us humans to read. Computers, of course, really don't care about the spacing on that, but when you're looking at something, you want to make sure you're displaying it, making it easy to read. Those three quotes make it very easy to check to make sure that your components you're working with either A, look nice for other people to read, or in the case right here of the JSON file, making sure the JSON file is properly formatted, because you can see that the squiggles all line up properly and the commas separate the different values. Great thing right there. We then have a little bit of a JSON sample system right here. And so as you can see right here, each of the different JSON keys, we have ID, year, goal, and creature. And each of those keys are unique, of course, within each individual JSON entity. But each of them, as we go through, as we look through each of the one, it's like one right here, one right here, one right here, and right here. They all have the same set of keys. So this is very easy that we can, oh, this is a JSON array of all the same things. We can easily keep track of that. It's going to be really easy to work with and parse. As you can see also, when we're talking this JSON, we have an ID as a alphanumeric sequence. Then year is all an int or an integer value. Goal is another string, and creature is also a string, so we're working with those. And we then have that, after we have that lovely little sequence and we generate those values of those bucket list items that my students have, from this case, year 2017. We have some examples from 18, 19, and currently year of 2020. But we have some other examples of this. This is just a quick little demo so we can see what's going on with it. But we take that string value, and then we're going to encode it as a data, because we want to actually use a data for this, and that's not going to be a string, because we don't guarantee that we're working with, especially when we're getting things off of the internet, that actually is a string. So we want to actually encode it as a data. And we're using the UTF-8 encoding. Now this is guaranteed to work right here because this is a string. We just typed it up. It's just regular text. So UTF-8 encoding is definitely going to fit within this. But because it's not a guarantee, we have this exclamation point right here afterwards where it's doing a force unwrap. Now, you would never, ever, ever use the exclamation point on anything that's going to production or live code because you don't want to risk crashing your entire app just because of it. So the exclamation point is only if you can guarantee that it's automatically there. Like say, for example, you just typed it up yourself and it's guaranteed to work. But most of the time, that's not the guarantee. Either use the do try, or you have something inside there where you can use give it a guaranteed value as a default just in case. But because I've got it right here, we're good to go. The next thing we have is we have the struct that we're going to be actually converting the JSON values into. Now, as you can see right here, it's not just a plain struct, it's a struct that conforms to two separate protocols. The first protocol that it conforms to is codable, the second is identifiable. The codable protocol is actually pretty easy. It just means that everything inside this entity that we're working with, this struct, is also codable, aka it's basic and easy. So if it's an integer, if it's a double, if it's a boolean, if it's a string, or any collection of those things, we're totally good to go. And since our JSON values we're working with are all totally just text-based, it'll easily fit within that, so it's definitely guaranteed to be codable with that. You could even use an array of things if you wanted to, but we'll talk about that another time. The second protocol that we're conforming to is identifiable. Identifiable makes it so we can easily find things and work with things and identify them. And identifiable requires we have a variable named ID, and that variable itself is unique. Now, with the variable I'm working with right now, with the ID that we're working on here, it's an alphanumeric sequence where it has a random number, a sequential series of letters to go in the middle, and then another random number. So it's guaranteed to be unique because of the fact that sequential generation is going to keep on going and get bigger as it goes along, and we've got random numbers on both sides of it, so hey, we've got unique stuff, we're totally good to go. But that could be anything that you want. Maybe you're using a UUID or some other tool to actually guarantee a guaranteed unique value, but again, that's something we have to worry about for this. Then we have, again, the year, the goal, and the creature, and those match directly to what we see inside the actual data set. And so that's what our struct is doing. It's just a quick way of holding the things that we're looking inside that actual JSON file. The next bit we have is when we're actually going to put together and take that JSON and squish it into something we can work with in Swift. So the first thing we have to do is create a JSON decoder. That's where on line 40 I say let decoder equal JSON decoder. So I'm going to create an instance of a JSON decoder. And then on line 41, I'm going to see if I can turn that JSON data into an array list of bucket list items. So I have decoder.decode, and then I have it as the parameters for the decode. I take a list or array of bucket list items and from the data source we're looking at. And so can I turn the demo, that variable that's above that we encode with UTF-8, can I turn that into an array list or array of bucket list items? And I can. It totally works. And so when I do that, I store it as the variable sample. And in this case, in line 43, I'm going to print sample sub3.creature. And again, you want to remember when we're talking about using data structures in languages like Swift, like Java, like C, and any of its subsequent languages, when we're talking about indices, they always start off at 0 and then work our way up to n minus 1. And so the third one right here, .creature, I'm going to go to 0, 1, 2, 3, and I look inside it and get the creature, and it should report that it's a unicorn, which it does. I could add one more line right here, and we can do sample sub1, and we can ask the first sample what its goal is. And so if I run that statement right there, I should get C# because I'm going 0, then 1, and looking inside that one, and I'm getting its goal, which is the C# value, because that student wanted to learn C#. And so this is a quick way you can see how we can actually use JSON data, work with it in Swift, and then go from there. Now, if you want to actually read JSON data from a file or from a URL, there's a couple more steps that you have to do, but the basic structure of how you can take existing data, turn it into a JSON, and work with it is right here. Take a look at some of my other videos and see how you can make that happen, do some more. But thanks again. Cheers. Have a good day.